Good morning, all. Today we are going to see about architecture 8085 architecture. So already gone through a few blocks, or you can say a block diagram of 8085. So we have gone through few functionalities of 8085. Now we are going to see architecture, right? In detail explanation on architecture of 8085. So let me share my screen first. Yes, is it visible? Is my screen visible? Okay, that means you are able to see my screen. Okay, so this is basically architecture of 8085. So I'll give you first brief introduction on all the things which are involved in this architecture, or blocks which are there in this diagram. So uh, first here is we'll start from right side block, right? So we'll start from right side downward. So direction or point is here. This is my address buffer. This is my data and address buffer, right? So this address buffer is of 8-bit, data and address buffer, or multiplex buffer is of 8-bit. This is my register array, right? So how many registers are present? There are so many registers. I'll give you in detail idea on register uh, here, right? So this is about register array. Here it is instruction register, right? Instruction register holds the instruction. Again, this is my instruction decoder and machine cycle encoding unit, right? So this is generally used to decode the instruction and create the or pass the machine cycles to timing and control unit. Timing and control unit is located here. Timing and control unit generates the control signal. It will control all the blocks which are present over there, and also creates the specific signal for all the blocks, right? Here it is my arithmetic and logic unit, which is used to perform the operation. Here it is flag registers, which are using to store the status of the operation. Those are two registers of 8-bit. One is accumulator and another one is temporary register. Keep in mind that accumulator always holds the result, right? In case of 8085 operation. So accumulator is used to store the result. Accumulator is used to store the result. Temporary register is used to store temporary data, and which is near to processing unit, right? So temporary register is to store the temporary data which is used for operation, right? Next is interrupt control unit. Interrupt control unit is used to generate an interrupt and handle an interrupt which are there in processor, which is directly connected to data bus, right? And this is serial IO control, wherein you can have serial input output, right? Input and output is there, which is a kind of serial type. So serial IO control is used to send and receive data to microprocessor serially, right? So this is how all blocks are there, right? So we'll go to this architecture. So starting with address and data bus buffer, right? So address is basically how many bits of address is there in 885? Hmm? How many bits are there? Are you with me? Are you with me? Yes. How many bits are there in address? Hmm? How many bits are there? Total 16 bits are there in address, right? So uh, address bus carries 16 bits, right? So those two rather buffers are used to store 8 bits. So rather first 8 bit is stored here in address and data bus, and last 8 bits which are there in this higher order address bus, right? So this is lower order address bus and this is higher order address bus. This is basically a multiplex bus wherein you also can carry data from this. So in first, or you can say in first clock cycle, it will always pass an address to from this address bus, and after that remaining clock cycle holds the data, right? In any operation there are multiple clock cycles are present, right? If suppose my instruction is of is like add a comma b, in that case it will pass opcode as well as data, right? आता ह्या instruction मध्ये data नाहीये, it will purely on basis of opcode. But suppose that if my instruction holds an opcode as well as data, opcode stands for operational code, right? So operational code काय असतो हे तुम्हाला पुढं कळेल. मी तुम्हाला इन जनरल ज्यावेळेस प्रोग्रामिंग 885 करणार ना, त्यावेळेस तुम्हाला सांगणार आहे की what all procedures are there, how flowchart is there for program, then how actually program is converted into machine language, what is opcode, how that opcode is treated by प्रोसेसर, राईट? हे इन डिटेल मी सांगणार आहे प्रोग्रामच्या वेळेस. टाइम बिंग इतकंच लक्षात घ्या की एव्हरी इन्स्ट्रक्शन हॅज इट्स ओन ऑपकोड, अँड ऑपकोड इज ऑपरेशनल कोड, राईट? That opcode is taken from memory, right? So as and when you write your program, you convert your high level program into opcodes, right? So that opcodes are stored into memory. If suppose this is my memory, which has address of 100, 101, 102, 103 and all, right? So opcodes, right? Opcode is stored there. That means this is my instruction, add B. So add B holds an adder, this kind of opcode. 80 hex is value. 80 hex means in binary 1000 0000. This is my 8, this is my 0, right? So this is 80 hex that I need to pass on to address bus. So that address is carries. If this is my instruction add a comma b, then that instruction or address of that instruction. So this is my address, which is uh, there inside this. So address should be there. So you need to store address as well. So address is passed from this. Where actually address कुठं स्टोअर केलेला असतो? It is there in program counter. म्हणजे काय? तर हा प्रोग्राम आहे, right? Program is stored here. 7B, then 5C, 8A are few hexadecimal codes. So you can say opcodes are there, right? And those are my memory location, right? As and when you write your program, you basically give this initial address to program, right? So if this address is 100, initially program counter holds 100 there, right? The 100, rather the program's address is there in program counter. Since program counter holds the address, program counter is of 16-bit. Even stack pointers are also holds the address. So program stack pointer is also 16-bit. Increment and decrement address latch is basically used to increment and decrement addresses, right? So this is also of 16-bit, right? So first, initially, when you write a program there, opcodes are stored inside memory. First address, or you can say initial address of any program, you need to give it to program. And in this case, or in architecture, that address is stored in, initially that address is stored in program counter. That address is passed to address bus, right, in first clock cycle. So address bus holds that address, so it will start searching the memory location, right? So memory location is searched by address and data bus. This address bus initially is going to search and it will find the location here, right? So address location is there. So they find out address location 100 there, and it will fetch data which is there in this. So instruction is there. What instruction is there? This instruction, or add a comma b instruction is there, and address of that instruction is there, 80 hex. So processor fetch that data or 80 hex or instruction from there, and it will pass on data bus, and data bus will send that instruction to instruction register, right? So 80 hex is basically instruction, and that instruction is passed to instruction register. So instruction register gets the value 80 hex, right? So initially it holds the 80 hex there, right? So instruction is again passed to instruction decoding unit, right? So 80 hex possibly be the value which will not understand by processor. Since instruction register holds the instruction, it will pass that instruction to instruction decoding unit. The instruction decoding unit, what it will do, it will identify that instruction, right? That means it will decode, it will find out meaning from that. It is basically a binary number, or you can say binary values are there. It will find those binary numbers, what are all those binary numbers are there, and find out meaning from that, right? So what the meaning is there? The meaning of that instruction is addition, right? So it will find that the instruction is of addition. That means if it finds an addition instruction, that means what you need to do here is you need to generate a control signal from here. Sorry. If it is decoded, that this instruction and decoding unit find out that if this is addition instruction, that means there should be a source and destination, or you can say destination and source could be there as well. So it will find what source and destinations are there. So accumulator is there, and B register is there. Where is B register? B register is there. So it will generate a signal just to read data from that, right? So it will read the data. So it will generate a read signal as well, and read the data from this as well as this. So my values are there. If suppose my accumulator holds 02 and my register B holds the 04. In that case, it will generate a read signal. And what you need to do, this is my source, this is my first value, this is my second value. I need to add those values, right? So first value is there in accumulator, and second value is there in B register. So what you need to do, you need to pass those values for processing, right? So in initial case, this value basically takes from register array and keeps it in temporary array, right? Or temporary register, sorry. So this is taken from this and keep it in temporary register. Arithmetic logic unit took all those values, that is 0, 2 and 0, 4, and try to process this. Since it is addition, it will add the thing, right? So it will generate the result like 0, 6. So where is my destination? Where I need to store the result? That is there inside this instruction. The instruction is सांगितले की तो result कुठं store आहे करायचा आहे. So the meaning of this instruction is add register A and register B. That is add values or content from A and B and store the result into accumulator. Right. So this is going to add the result of addition and store this into accumulator. So accumulator is going to overwrite, right? So 0602 is overwritten and the value it holds is 06, right? Which is addition of register A and register B, right? So this will add processing, arithmetic and logic unit will process and add those values and store the result into 06. Here it is flag register which is mentioned, which stores the status of all those things. What all statuses are there? Sign flag is there, zero flag is there, AC flag is there, then parity flag is there. So in this, no, what is my result is 06, right? 00000110. So what is my how many ones are there? If suppose two ones are there, that means even parity. That means parity flag is set. So such kind of flags are set over there in flag register. Even though if sign is there, even though the result is positive, so sign flag is not set. If the result is negative, in that case, sign flag is set. So sign flag is becomes one there in flag register, right? So arithmetic unit or statuses are stored here, and exact result is stored in accumulator, right? So this is how basically a program works. So this is basically for one instruction. This operation could be carried for only one instruction. What will be about next instruction? Now, how you will find that address of next instruction and what is my next instruction, right? So as and when you pass the first address, right? As and when you pass the first address to address and data or rather address bus, this program counter loads the second address. Why and how? How many cycles are there for each and every instruction? How many cycles are there? How many processes are there? See, fetch, decode, and execute, right? Those all are rather that is basically a process for each and every instruction. Every instruction should be fetched, decoded, and executed by microprocessor. So in that case, as and when fetch operation is completed, this microprocessor or other blocks are trying to decode and execute. Basically, those two blocks are they're involved in decoding. This ALU and control unit and accumulator and all and register array all are trying to be there or all are involved in execution, right? So two blocks are there for decoding, other blocks are there except program counter and address bus all are there in execution, right? So in that case, this program counter is free when my instruction is decoding and executed, right? So in that case, when this processor pass 100 on address bus, next instruction is stored inside this, right? Next instruction or next address, that is 101, is stored in program counter. So while you are executing this first instruction or 80, while you are executing this first instruction, your program counter will load next address, right? Program counter will load next address into it, right? From address location. Since it is, or since your program is sequentially stored over there, right? That is why that is why basically program counter, in definition, there is written that program counter always holds next address. That means your, as and when you try to decode and execute your instruction, program counter holds the address of next instruction, right? And that is because program counter is called as it holds an next address of next instruction, right? This increment and decrement address latch is used to increment and decrement the values of stack pointer and program counter. So when you pass 100 to this, no, increment and decrement address latch will increment the address location of program counter, and it will go there inside this, and 101 will be stored there in program counter, right? इथपर्यंत कळलं का? Up till now it is clear to all. समजलं का एक्झॅक्टली काय होतं एक इन्स्ट्रक्शन घेतल्यानंतर? Okay. So if suppose my next instruction is STA to 1105 text, right? That means store accumulator to this location, right? Store accumulator to this location. So here it is, my location is 105x. So next instruction would be STA 105. That means this instruction could be store whatever is there in accumulator to this thing. So where is my program? My program is at 101 and I need to carry that as well. So what it will find? It will find this address, right? So the location which is there should be searched, right? So next instruction could be uh, there in instruction register. Instruction register will pass this instruction to instruction decoder and machine cycle. It will generate machine cycle. It will generate control signals. What control signal it is generated? Since it is ESA, that means your story, you are going to store, or your microprocessor is going to write some data which are there with accumulator into memory location. So it will generate a write signal and find out the memory location. So it will pass the memory location from this address bus, and then it will find out this location 105, and whatever is there as an address there, an accumulator, should be passed from this data bus, right? In next cycle, that data is passed from this data bus, and it will copy, or it will store that data which is there in accumulator into next location, or you can say 105th location, right? This is basically my next instruction. And this process carries out, right, just like this process. Then again, my program counter holds the next address, whatever is there as instruction which was stored in instruction register, it is decoded, whatever meaning of that instruction is find out and generate a control signal for that, right? This is basically the architecture, or this is basically a microprocessor work there. Now, what all registers or remaining registers are there? So basically, B and B, C, D, E, H, L, right? So totally six general purpose registers are there, or you basically say that eight general purpose registers are there, which is of 8 bit, right? 8 bit general purpose registers are there. From that, B, C, D, E, and HL, those all registers are used by programmer, right? म्हणजे काय तर हे जे कॉम्बिनेशन्स आहेत बी सी डी एच एल ते तुम्ही यूज करू शकता. W and Z registers are not, or you can say access of W and Z is not given to programmer. W and Z temporary registers access is not given to programmer, since this access is only with this access is only with microprocessor. म्हणजे काय तर हे 8 बिट रजिस्टरचा ऍक्सेस जो आहे तो फक्त मायक्रोप्रोसेसर कडे आहे. सिन्स हा जसा आहे टेम्पररी रजिस्टर ना, which that temporary register is used in operations just like that. Those temporary registers are also used by processor or microprocessor for operations, right? As and when it started operating, those temporary registers and accumulators are used to rather used for operations. So access of W and Z is not with programmer, but B, C, D, E, and HL, those are used basically for storing data, and combination just like B, C, D, E, and HL is used as 16 bit to store 16 bit data, right? So जर तुम्हाला 16 bit data store करायचा असेल तर तो कुठल्या कॉम्बिनेशन मध्ये करायचा? You can store 16 bit data in B and C register, or D and E register, or H and L register, right? So याच्यासाठी 16 bit जर डेटा स्टोअर करायचा असेल तर ते तसं कॉम्बिनेशन आहे. You can store your addresses. That means if programmer wants to store his address, then EHL register basically used to store the address. That means a programmer wants to store his address, then his or her address, then EHL register basically used to store address there, right? So HL register ni तुम्ही ऍड्रेस स्टोअर करू शकता रादर एचएल मध्ये, आणि डेटा बी सी डी हे 4 रजिस्टर आहेत ते तुम्ही डेटासाठी यूज करायचे आहेत. आणि ऍड्रेस ज्यावेळेस तुम्हाला ऍड्रेस स्टोअर करायचा आहे, you are going to store that address into EHL register, right? So this is how this register is used. What is use of stack pointer, right? Stack pointer कशासाठी यूज होतो हे मूव्ह करतो मी आता. स्टॅक पॉइंटर लक्षात त्याचे लोकेशन लक्षात आले असेल. बट स्टॅक पॉइंटर, राईट? स्टॅक रिजन मेमरी असते, राईट? स्टॅक रिजन असते. स्टॅक म्हणजे काय? स्टॅक म्हणजे काय? व्हॉट इज स्टॅक? व्हॉट इज स्टॅक? अरे तुम्ही डेटा स्ट्रक्चर शिकतायत आता, बोला पटापट. व्हॉट इज स्टॅक? तुम्ही स्टॅक सांगितलं तर मी पुढचं शिकवणार, नाही तर सोडून देणार आहे. बोला पटापट. इथं प्रवचन ऐकायला बसलेलं नाहीये तुम्ही. हा, नाही आवाज नाही आला. कोण काही बोललं का? Okay, Samruddhi said that stack is collection of data with first in last out. Okay, so it is basically structure. अजून कोणी बोललं का? आवाज मला नाही लक्ष, माझं लक्ष नव्हतं. कोण होतं? Arrangement of same object in particular order. हे असं नाही म्हणता येणार. बेसिकली तुमचं स्टेटमेंट इंग्लिश मध्ये जरी करेक्ट असेल तरी ते प्रोग्रामॅटिक वेनी तितकंस हे नाही. सो तुम्ही चेक करा थोडंफार, राईट. ऑब्जेक्टच्या केसेसमध्ये तुम्हाला इथं नाही बोलता येणार. सो ठीक आहे. स्टॅक इज बेसिकली, आता स्टॅक तुम्हाला माहिती आहे, राईट. सो दॅट मीन्स यू नो दी use of stack, right? So how basically stack works, in this case, the stack memory, right? Stack memory is used for sequential access therein microprocessor, right? This sequential access is carried out by this stack, right? Where actually stack is located. So in earlier versions, this stack is basically there at the end. If suppose this is my primary memory or this is my RAM, in that case, at the end, you have few locations which are there, keep aside, right? And those memory locations are used like stack, right? आता हे memory locations stack सारखे use करत होते in case of microprocessor in 8085, right? Where actually this is used. So this stack, rather, we'll see first about stack pointer, right? So this stack pointer holds the address of stack, right? Address of stack memory. So if suppose this address is 500, 501, 502, 503. Basically, this is in decremental order since it is at the end, so you will get the address in decremental order, basically, right? So त्याचा जर तुम्ही एंडला आहेत ना, तर ज्यावेळेस तुम्ही मूव्ह करता त्यावेळेस तुम्ही मेमरीच्या आत जाताना तुम्हाला डिक्रिमेंट व्हावं लागतं, राईट. तर तुम्हाला नेक्स्ट लोकेशन भेटतं सिन्स इट इज ऍट दी एंड. हे बेसिकली लक्षात ठेवा, फक्त कन्फ्युज होऊ नयेत म्हणून मी इन्क्रीमेंट ऑर्डरनी लिहिलंय. पण त्याचा एक्झॅक्ट यूज कसा आहे तर ते डिक्रिमेंट ऑर्डरनी व्हॅल्यू स्टोअर करत जातात. सो स्टॅक पॉइंटर बेसिकली होल्ड्स दी ऍड्रेस ऑफ stack region where is used this in, if suppose my programs are there 100, 101, 102, 103. If suppose this is my another program, or you can say this is my subroutine, right? सबरूटीन असेल तर त्या केसमध्ये काय होतं, इथून माझा हा प्रोग्राम एक्झिक्यूट होत आलाय आणि इथं हा सबरूटीनचा ऍड्रेस आहे. म्हणजे काय, तर इथल्या प्रोग्रामला त्याच्यातनं पास होणाऱ्याला रिझल्ट पाहिजे, राईट. सो या केसमध्ये काय होतं की वेन यू वॉन्ट टू ट्रान्सफर द कंट्रोल ऑफ प्रोग्राम फ्रॉम वन रिजन टू अनदर, त्या केसमध्ये काय करतं की हा जो ऍड्रेस आहे, राईट, रादर हा ऍड्रेस स्टॅक पॉइंटर काय करतं, स्टॅक पॉइंटर घेतं, स्टॅक पॉइंटर वरनं स्टॅकचा ऍड्रेस घेतं, राईट, आणि स्टॅक रिजनला हा स्टोअर करतं, राईट. स्टॅक रिजनला हा स्टोअर करतं आणि स्टॅक इन्क्रिमेंट करतं, राईट. या केसमध्ये हा ऍड्रेस म्हणजे काय, तर हा ऍड्रेस तुम्ही स्टॅक मध्ये स्टोअर केला आणि प्रोग्राम काउंटर मध्ये ऑब्विसली काय असणार आहे, हा ऍड्रेस असणार आहे 102. तो प्रोग्राम काउंटरचा ऍड्रेस काढून टाकायचा आणि प्रोग्राम काउंटर इज लोडेड विथ 700, right? And this address is stored again in stack pointer. So stack pointer is here, right? Now it is in 501. Program counter is loaded with 700, and again this procedure is carried out, rather this sequence is carried out till 703, since program counter is incremented after each and every instruction. So when it ends, no, you need to give control return at this location only or next location, basically, right? Not this, at next location. So sorry, 700, 700 नाही, सॉरी, इथं वन हा ऍड्रेस स्टोअर होतो 102 x, right? सो हे काय करतं की प्रोग्राम काउंटर विल pass this to next location. So at the end, when this subroutine completes its execution, it needs to return. When it gets an return instruction, then it will find again the stack pointer. In that case, stack pointer holds the this location. So it will decrement again and come to this, right? So this location, or you can say address of next location would be there with program counter, not 102. 103 is with program counter. That 103 will be passed again to program counter and loaded into program counter, right? So in case of return, it will one program counter again is loaded with 103 and stack will return that value to program counter, and program counter will take that address and start again this sequence, right? So this routine is subroutine is executed and it will return to this and it will again carry out its task. So in that case, stack memory is used and stack pointer is used. So stack pointer always holds the address or top address of stack memory, where basically stack memory is used in such scenarios, which is we see there in such scenarios, this stack memory is basically used. समजलं का हे समजलं का काय होतं? येस, नो. ज्यांना समजलं नाही तेही सांगू शकतात की समजलेलं नाहीये. समजलंय? स्टॅक पॉइंटर काय करते समजलं? स्टॅक पॉइंटर होल्ड्स द ऍड्रेस ऑफ स्टॅक मेमरी, वेअर बेसिकली स्टॅक मेमरी इज यूज. जो आता आपण सिनॅरिओ डिस्कस केला त्या सिनॅरिओ मधच्या केसमध्ये स्टॅक मेमरी यूज होते. सो स्टॅक पॉइंटर इन्क्रीमेंट डिक्रीमेंट स्टॅक मेमरीवर पास करतो आणि इन दॅट केस जो काही डेटा आहे परत तो पास करतो, राईट? सो दिस इज बेसिकली used rather stack pointers, right? Used for stack pointer is used for, rather stack memory is used for in such scenarios. Stack pointer is used to address the stack memory, right? So this is basically about uh, stack pointer. One more thing which is there about, flag register. Now flag register is of 8 bit, right? A flag register 8 bits आहे म्हणजे काय? Obviously 8 bits असणार आहेत. 0, 1, 2, 3, 4, 5, 6, 7, 8, right? So this is 8-bit flag register and started from bit D0, D1, D2, D3, D4, D5, D6, D7. Okay. Oh shit. Okay. So those bits are written like, you know, this is my C flag, parity flag. Then this bit is AC, then 0, and then sign. Now, what all those flags are? म्हणजे रिझल्ट स्टेटस कसा सेट होतो रिझल्टचा? जर तुमच्या रिझल्ट मध्ये कॅरी जनरेट झाला तर हा फ्लॅग सेट होतो. सेट म्हणजे काय? 1. That means in case of this, if my result or carry is 1, it is carry flag or carry is generated by operation. Otherwise, it is in reset state. That means 0. This is, about parity flag. This is my parity flag. This is carry flag. Parity flag, when it is, if results parity is even, it is 1. If result parity is odd, it is 0. Just hold on for a while. तोच आहे ना even ला 1 odd ला. Okay. So he consider that even 1 odd 0, right? Parity flag. Parity म्हणजे काय? So whatever is your result, it will check how many ones are there, right? How many ones are there, and it will count those ones. If it is even, flag is set. If it is odd, it is reset, right? So parity is even in that case. जर इथं 1 असेल तर इवन पॅरिटी आहे रिझल्टची. जर इथं 0 असेल तर ऑड पॅरिटी आहे रिझल्टची. इथं 1 असेल तर रिझल्टचा कॅरी सेट झालाय. इथं 0 असेल तर कॅरी जनरेट नाही झाला रिझल्टचा. नाउ दिस इज व्हॉट इज ऑक्झिलरी कॅरी फ्लॅग. ऑक्झिलरी कॅरी फ्लॅग. ऑक्झिलरी कॅरी फ्लॅग म्हणजे काय? तर हा रिझल्ट आहे. 1 2 3 4 8 बीट आहेत. जर D3 किंवा बीट 3 मधनं बीट 4 ला जर कॅरी जनरेट होऊन पास होत असेल, राईट, म्हणजे हे ऍडिशन करतोय, बीट 3 मधून बीट 4 ला जर कॅरी जनरेट होऊन पास झाला, इन दॅट केस दिस फ्लॅग इज सेट, अदरवाइज इट इज रीसेट. दॅट मीन्स जर 0 असेल तर D3 बिट कडून किंवा B3 बिट कडून B4 बिट कडे ऑक्झिलरी रादर कॅरी पास नाही झाला. दॅट मीन्स इट इज reset, right? So this is auxiliary carry flag. This is zero flag. Zero flag म्हणजे काय? If your result is 0, then this flag is set. If your result is non-zero, reset म्हणजे 0. That means हा 0 असेल तर नॉन झिरो आन्सर आहे आणि हा 1 असेल तर सगळंच आन्सर 0 आहे. Sign flag. Sign flag is set when, that means हे 1 असेल तर निगेटिव्ह रिझल्ट आहे आणि हे 0 असेल तर पॉझिटिव्ह रिझल्ट. दॅट मीन्स इफ रिझल्ट इज निगेटिव्ह, युअर फ्लॅग इज सेट, म्हणजे हे 1 असेल आणि रिझल्ट जर पॉझिटिव्ह असेल तर हे 0 असतं, राईट. सो दिस इज हाऊ फ्लॅग रेजिस्टर वर्क्स. तो ते रीड कसं करतं, तर ते परत ह्या व्हॅल्यूज मेमरीमध्ये किंवा अक्युमुलेटर मध्ये स्टोअर करतं आणि रीड करतात की कुठले कुठले रादर स्टेटस काय आहे ऑपरेशनचा. म्हणजे त्याचा कॅरी जनरेट झालाय का, त्याची पॅरिटी चेक केली जाते. ऑक्झिलरी कॅरी सेट झालाय का, म्हणजे D3 बिट कडून D4 बिट कडं कॅरी पास झालाय का, रिझल्ट 0 आहे का नॉन झिरो आहे. साइन फ्लॅग म्हणजे तो निगेटिव्ह आहे का पॉझिटिव्ह रिझल्ट आहे. दिस इज हाऊ स्टेटस वर्क फॉर दिस रिझल्ट, राईट. सो हे झालं फ्लॅग रेजिस्टरचं. बाकीचे आपण डिस्कस केलेत. अक्युमुलेटरचं एक लक्षात घ्या की in case of 8085, always or most of the time result is there in accumulator, right? Most of the time result is there in accumulator. So this is how basically the architecture is for 8085. हे समजलं का? त्याच्यात काही इश्यूज आहेत का? I'm going to stop recording here.